So the absolute value of x minus 2 equals 6. What's the idea of this problem? Well, forget the x minus 2 for a second. Just think the absolute value of something, some unknown thing, is 6. Where can that thing be if it's going to have an absolute value of 6? That unknown thing can be at 6 because the absolute value of 6 is 6. Or the unknown thing can be at negative 6 because the absolute value of negative 6 is positive 6. Remember, the absolute value of a number is its distance from 0. Both of these are 6 away from 0, so they both have an absolute value of 6. Well, now we can take the question mark, which is x minus 2, and we can write down a couple of equations. X minus 2 could be negative 6, which is the tricky one, or x minus 2 could equal 6, which is the one you would get if you just came over here and ignored the absolute values. So people who don't know what's going on sometimes just ignore the absolute values. They get this equation, they add 2 to both sides, they get 8. They notice that 8 works, and then they just leave that answer. And they're, of course, wrong because they're missing the other possibility. If you add 2 to both sides here, you get x equals negative 4, which also checks because negative 4, take away 2 is negative 6, and the absolute value of negative 6 is 6. So both of these are solutions, and the or means, of course, a union of the two. So if you want to write these in set notation, you could write them in set notation this way, but I would accept x equals negative 4 or x equals 8 as well as the set notation. Very much like the last problem, except there's some steps to get started with. We can't do algebra inside absolute value signs, but we can do algebra outside. So if we're trying to get a handle on this absolute value of q, it's okay to do this because we're not dealing with numbers inside the absolute value sign. And then we could divide both sides by 7 because, again, we're voiding anything inside the absolute value sign. But now we have to decide what's going on. And if you have the absolute value of something called q equaling 1, then q could be in either one of these places. So q could equal negative 1, or q could equal positive 1. And we could write that in set notation this way. And we could even use plus or minus, because this means plus 1 or minus 1. So there's all different kinds of ways we can write this. But the thing you cannot do is be a little bit unsophisticated and just say, well, I don't understand the absolute value, so I'm just going to put q equals 1 and be done. That just gets no credit at all. You have to understand the possibilities. When you have an equal sign, an equation built out of two different absolute value quantities, what's the idea? Well, let's just go over here and think about numbers instead. Say you've got 6 here, and you know that the absolute value of 6 equals the absolute value of some other number. What are the possibilities? Well, it could be a 6, because the absolute value of 6 equals the absolute value of 6. But the other number could also be negative 6, because the absolute value of negative 6 is positive 6, because these are both 6 away from 0 on the number line. So that means there's two possibilities here. One is the obvious one that people get even if they don't understand the problem. If x plus 4 equals x minus 3, then the absolute values will be equal because they themselves are equal. That's like having the absolute value of 6 equals 6. We can solve this, we will solve this, everybody gets that one. But the one that requires some knowledge, the one that you really need to know to get credit for this in a Math 89 class, is that x plus 4 might equal the opposite of x minus 3. Because the opposite of x minus 3 has the same absolute value as x minus 3. That's the way the absolute values work. So here, when we try to get x by itself somehow, we take away x from both sides. And we get 4 equals negative 3, which is never true. X has disappeared from the equation. It's never true no matter what x is. So this does not lead to any solution at all. This just doesn't help us. So this one over here is the one that's going to help us. Let's distribute the minus sign through the parentheses. Notice minus a negative 3 is plus 3. Let's add x to both sides. Let's subtract 4 from both sides. Let's divide both sides by 2. So I'm getting x equals -1/2. If you want to, you can check that by trying it out in the equation, but you will see if you put in x equals -1/2, you'll see that you get 3 1/2 equals 3 1/2. So you might want to check it. In my opinion, that's a good enough answer. Our book likes to use set notation, but when a set has one thing, it's hard to see the advantage of set notation. This seems like a pretty good answer to me. So here we can't subtract 3 from both sides or anything. You can't do algebra inside the absolute value sign, but this 8 we could subtract from both sides to make things a little bit simpler. So we have the absolute value of m plus 3 is less than or equal to 6. Now we've got some troubles. So let's go over here and let's think about the absolute value of something being less than or equal to 6. And the something will be m plus 3, but let's just think of it as a question mark. Now where can that something live on the number line? This is supposed to be -6. It's not very good. Let's get rid of it. That's supposed to be 6 and this is supposed to be 0. Okay, so where can we put the question mark? For instance, can we put it out here to the right of 6? And the answer is no, because it'll be something like 7 or 8 or 9. And the absolute value of 7, 8, or 9 is not less than or equal to 6. So the question mark can't be out there. And it similarly can't be out here. In fact, the question mark has to be in here. That's where it has to be. So one very good way of setting up this problem is to say, well, look, this thing that we're trying to find the absolute value of, this thing has to live somewhere in between -6 and 6. And it could equal -6, so I put it or equal to. It could equal +6. So the m plus 3 has to be in there. Now when you have a string of inequalities with a less than and equal to and then another less than, this is smaller than this, which is smaller than this, you can in fact take away 3 from all 3 parts of this, left, middle, and right. It's kind of cool. It's kind of fast, which is why I want to do it. And this tells us -9 is less than or equal to m, and m is less than or equal to 3. So it is in between -9 and 3. Now I did not read the directions, so I'm going to go look at the directions. Write the answer using set builder notation, interval notation, and graph the answer. So I'm going to graph the answer. First, -9 is part of the solutions, 3 is part of the solutions, and everything in between. This is where m has to be. M has to be in between -9 and 3 for this to be true. Let's just try it out. 0's in here, isn't it? Isn't 0 in between -9 and 3? So put a 0 in there. 0 plus 3 is 3. The absolute value of 3 is 3. 3 plus 8 is 11. 11 is less than or equal to 14. So 0 did work, so that's pretty cool. Let's do set builder notation. Set builder notation will be the set of all m's such that that is true. Let's do interval notation. The far left is -9. The far right, the biggest, is 3. 3 is included, we use brackets. -9 is included, we use brackets. This is interval notation. This is set builder notation. And this is a graph of the solutions. And notice, all these shaded numbers make this true. And everything bigger than 3 and smaller than -9 make this false. So we've got a picture of the solutions, we've got them described with set builder, and we've got them described with interval notation.